All right, welcome back, everyone. So you've seen the video of the ball rolling across the floor and had a chance to describe what you think is going to happen. And I'm going to talk to you a little bit about what I noticed. I'm going to think a little bit about whether I need to make any assumptions in examining the motion of the ball. And then I am going to draw us a motion diagram for the ball. I think the way I would describe the motion of the ball in words here is the ball is rolling. It is rolling to the right. And it looks like the ball is possibly slowing down a little bit in between the two green pieces of tape. There are other things I could add in there. For example, I could think about, is it rolling in a straight line or does it change direction a little bit? Is that straight line perpendicular to the green tape? So lots of things that you could have talked about. This is actually a rich example for being so straightforward. A thing that I want to draw particular attention to here is, did we make any assumptions in that description? Or did you make any assumptions when you were thinking about it? I think particular things where you might make an assumption here are, is the ball rolling in a straight line? If you look really carefully at the ball, it probably doesn't roll in exactly a straight line, but it might be a good approximation to treat it as if it were moving in a straight line. Similarly, you might have debated whether or not the ball was rolling with constant speed or whether it was slowing down. And again, you might decide that it's easier to examine the system if it's moving at constant speed. Let's go ahead and draw a little motion diagram for the ball, just like we did earlier for Dr. Paz. Once again, a motion diagram is a simplification. So I'm going to draw the ball as a little ball rolling across the floor here. And I'm going to try to capture it at different snapshots in time. Now I'm going to make those two assumptions that I made earlier, that the ball is rolling in a straight line and that the ball is moving at constant speed. So that means that as I draw these snapshots, they're all going to be, at the same height, at the same vertical position on my screen. And they should all be spaced out pretty equally. So actually that one I think is a little bit off. I'm limited in what I can do on Zoom here. So we're going to try our best. Let's see. I think 5 instance is probably plenty here. So 1, 2, 3, 4, and 5. So those would be the instants in time. Again, those are not necessarily meant to represent seconds, right? They're just instants in time. You could call them T1, T2, T3, T4, T5. And they are equally spaced out in time. That's a general, always true feature of motion diagrams. And because I assumed the ball was moving with constant speed, they're also going to be equally spaced in space. And one thing that I can do to show that is I can add extra things to my diagram, right? This is kind of the straightforward snapshot view. Motion diagrams can often have other things on them to help us out. The thing that I am going to add here is I could add position vectors. So maybe I measure with respect to Dr. Paz, who was over here, and I could add vectors that go from the origin, the reference point that I'm measuring from, to each position of the ball. And you'll note that I'm shifting these a little bit so they don't overlap with each other, since this I've assumed is a 1D problem. So those would all be vectors describing the position of the ball at different times. And I could label those if I wanted to, right? This one would be X5, for example. On the other hand, I could decide I want to label the velocity instead of the position. That's probably a more common thing that we will label in motion diagrams. And this ball is rolling to the right. So I would draw little vectors that look something like this to represent the velocity at different instants in time. And I would want to go label those, for example, V5, to tell me what the velocity is.